Alrighty, so we have a 500 grams, which is half a kilo of uranium-235, radioactive substance, right? And let's say it looks like this. It's this kind of block of uranium here. It looks like that, right? Alright, so this is our uranium-235, half of a kilogram right there. It's like a block of uranium, right? That makes sense, right? Think of it that way, right? Okay. And at the very beginning, right now, 0 half-lives, no years, like right now in this present moment, we have 500 grams. Are you with me? And that's what it looks like. So are you with me that this is a piece of material? And this piece of material decays, it disintegrates, it disappears as time goes by. And what this means, when we say half-life, we mean is half of it disappears after 700 million years. So half of this block is going to disappear. It's going to radioactively decay after 700 million years. Does that make sense? So that means after one half-life, which is 700 million years, right? I'll do big M. 700 million years. We're going to have how much remaining? Now just forget about what you've done. Forget about anything else. Just focus on this piece of paper and what we're doing right now. And we'll ask that again. What will be remaining after 700 million years? Yes, it would. Okay. Because that's what half-life means. After 700 million years, half of this block will have disappeared, right? And so we'll be left with that. This block of uranium, which is half as much as we had before. Make sense? Half. That's what a half-life means. After 700 million years, half of it is gone away, and we have half of it left. Okay? So we have 250 grams. This is 250 grams remaining. Okay? Now, after another half-life, how many years is that going to be? No, focus. I think you're looking at your paper again. We need to start all over again. Throw whatever you done. I want you to crumple up and throw it away. Start over. After another half-life, how many years is that?
So, okay, if we add 2, wouldn't we just have, like, cut the 700 million in half?
Okay. Another half-life is 1,400 million years.
Okay, we add.
Because the time is going on, it's further into the future, right? Okay, and how much have we remaining now?
125 grams?
Yes, 125 grams. Good. And it looks like this. It's half of this again. You take this one, you split again. You take this one, you split it in half. And this is what we have. Another half of a block, right? It's actually a quarter of what we started with, right? See that? Okay, so after 3 half-lives, what's the situation? How many years is that and what's left? Take your time. Don't rush it.
2,100 million?
Yeah, 2,100 million years. That's another 700 million years. That's the third half-life. And how much is remaining? Take your time.
75 grams?
No, take your time. You rushed it. Okay. Yeah, look, you're dividing this by 2. 2 into 1, 2, 5. 2 into 12 goes 6 times. 2 into 5 goes 2 times. And what's the remainder? 1. What's 2 into 10? 5. And the decimal point goes up here. 62.5 grams. Good. Okay. Okay, the next line. After 4 half-lives, what do we got left? Yes. 2,800 million years further into the future, and we have half again of what was left last time, right? No. Close. But okay, 3 into 6, 2 into 6 goes 3 times, 2 into 2 goes 1 time, decimal point goes up. 2 into 5 goes twice, remainder 1. What's 2 into 10? 5, 31.3, 31.25. See, the 62 got divided by 2 to give 31, didn't it? And 50 divided by 2 is 25, isn't it? Alright, so that's what we have left. So that'll answer that part of the question anyway, right? But the question is, if we're given an arbitrary number of half-lives like 10 or t, how can we just get the answer without, going step by step? Like, how do we just come up with a formula, right? So let's think about that. And I want you to think about how... aren't we having this as we go? Right? So like for 2 half-lives we halved 500 and then we halved it again, didn't we? Okay. So that might give us a clue as to what we would do if we wanted a formula to figure out what would happen after 10 half-lives, doesn't it? I mean, for example, how can I go from 500 to 250? You can go 500 over 2, correct. Is there another way of going from 500 to 250? Subtract 250. How else can I do it? What can I multiply by to get to 250? 5. There you go. Times what gives 250? Times 0.5, right? Yeah, or even times a half, right? 500 times a half would give 250, wouldn't it? That make sense? Good. So, I've got 250. How do I go from 250 to 125? Right, how else? You can divide it by 2. How else can we do it? No, you could multiply by half, not divide by half. So if you multiply 250 by half, you get it. If I started with 500, how can I get from 500 to 125? Yeah, multiplied by, go. No. Multiplied by a half and I get what? What's 500 times a half? What's 250 times a half? Okay, so multiplied by a half twice. Wouldn't that work? Oh, that's nice. There you are, to the power 2. Beautiful, right. So for 2 half-lives, it looks like I can go 500 times a half to the power of 2. Right? And that's going to give me 125. That's cool because that's a formula that includes this number 2 here. And it also includes the amount we began with, the 500 grams. And that's kind of useful, right? See, notice that? Notice what we just came up with there? Came up with a formula that includes the number of half-lives and 500, what we started with. That's really useful. So, how can I go from 500 to 62.5 after 3 half-lives? What would the formula be there, do you think? Yeah, because times a half gives 250, times another half 125, right? Times another half gives 62.5. right? And as you say, that's just 500 times a half to the power of 3. And that's awesome because that includes, so it says after 3 half-lives, I start with 500 grams, I times it by a half to the power of 3, and I'm good to go. And just for fun, let's plug that in a calculator. Right, because in the calculator it would look like this. 500 times 1 over 2 to the power of 3. Or you could do 500 star, and half is just 0.5. 0.5 to the power of 3. Right? So there's a couple of ways of doing it in the calculator. But the calculator understands PEMDAS. So it's going to do the exponent first and then multiply, which is fine. So you don't have to worry about parentheses with this way. Right? Anyway, so 500, and we'll put it in a calculator and see if it works. You know, times, let's say 0.5 to the power of 3, and I get that, right? Or I can go 500, parenthesis, 1 over 2 to the power of 3. Either way, whichever way you guys like, it's fine. Oh, I'm in math print. I gotta change my mode to classic. And just do that again. 500 times 1 over 2 to the power of 3. And I get that, right? Cool. Okay, so there we go. So, how about after 10 half-lives, how would I figure out what was remaining? Good job. To get the years, yeah, 700 million by 10, it'd be actually 7,000 million years. Good job. And what would how would I figure out what was left after 10 years? Good job. 500 times a half to the power of 10. Or like you say, 500 times 0.5 to the power of 10 in a calculator, and that'll give it, right? Okay, and so, I did the wrong thing there. I was like, Okay, 500 times 0.5 to the power of 10. And let's just round that because we're talking about what are we measuring this in? What's our unit of measurement here? Grams, right? And one gram is like a little pinch of salt or something, right? It's a small amount. So that's about, we'll just call that about 0.5 grams and be good with that. Okay, around half a gram. Make sense? So our half a kilogram after 700 million years has reduced to like a pinch of salt, right? Okay. Okay, so after T half-lives, how much would be remaining? And this will be on all of your tests and everything to figure out the formula, right? Okay. So, well, you got it for 10. Can you get it for T? Yeah. Yep. And that's all. That's all you gotta do. To the power of T. So after T years, that's what we do, right? After 10 years, that's what we do, and after T years, that's what we get, right? However that T, and that, by the way, that could be a decimal. It could be like 2.34 years half-lives. Sorry, 2.34, sorry, half-lives. In which case, you would calculate 500, times 0.5 to the power of 2.34. You know what I mean? So it doesn't have to be like a whole number. It could be a decimal. But yeah, that's the formula. Good job.